Today I'm going to talk about tripoles, a new class of relationships and time series data. In many domains, time series are being obtained as activities recorded at different nodes of a highly complex system. For example, climate data, where we record physical variables at different locations on the globe. Another example is brain fMRI data, that records amount of oxygen consumed in various parts of the brain. A common question of interest in such domains is, are there any relationships between the activities observed at different nodes? In the existing literature, relationships are most commonly studied between a pair of nodes. For example, in climate, we have dipoles that are pairs of locations with strong negative correlations in their sea level pressure time series. Similarly, in neuroscience, pairs of brain regions with positive correlations have been studied. However, in a complex real-world system, relationships can potentially exist beyond pairs of time series. Therefore, in this work, we take a step ahead and introduce a new class of relationships between three time series called tripoles. A tripole consists of three time series. Let's refer to T0 as root and T1 and T2 as leaves of tripole. Then, a tripole is interesting if the sum of two leaves shows much stronger correlation with the root compared to what they show with root individually. The jump in correlation strength indicates that each leaf has a partial piece of information about root. However, their pieces are complementary to each other. Hence, when they are added together, the variability in root is explained much more comprehensively. To illustrate this further, we present a real-world example of tripole from transportation domain. Consider a tripole of three time series of daily southbound traffic at three road stations. While the route T0 is being observed at a national highway, the leaves T1 and T2 are being observed at the roads that are its tributaries. Now let's look at the three time series. As you can see, the individual correlations between leaves and root are 0.42 and 0.25. Now let's add the two leaves. This time, the correlation strength jumps to 0.83. Now the question is, why do we see such a jump in correlation? This is probably due to inconsistencies in the contributions of traffic from the leaves across days. In particular, every Sunday, T1 experiences a drop in traffic while T2 sees a rise. Such inconsistencies weaken their individual correlations with root. However, the spikes and drops in the two leaves cancel each other out in the sum, resulting in stronger correlation with root. In this paper, we present a formal study on tripoles and address several research challenges that include how to quantify the interestingness of a tripole, how to find all tripoles efficiently from the data, and how to evaluate the discovered tripoles to distinguish between real and spurious ones. We found several interesting tripoles in the datasets from climate science and neuroscience domain. In fact, one of the tripoles led to the discovery of a new climate phenomenon that was unknown to climate scientists before. For further details, we encourage you to visit our poster and read our paper on Tripoles, a new class of relationships in time series data. Thanks for watching our video. See you in Halifax.
Created using Powtoon.